Hello. So in this video we're continuing our work on differentiation. Now we're going to move away from just purely differentiating terms, right? We're still going to need that. We're still going to need to differentiate functions, but we're going to look more deeply into the actual, study of differentiation now, right? So the first concept we're going to look at now is this idea of tangents and normals. Well, tangent obviously is what you expect, is what we've done before at GCSE. So if we have a given curve, say like this, then if we have a point P, let's say a point here, let's say point P, then obviously the tangent is going to be something like that, right? That's my tangent line. And it's going to be touching the curve at the point B. So tangents touch the curve at a point, okay? And so again, the idea of a tangent is that it gives you the gradient of the curve at that point. So and gives the gradient of the curve at that point. So tangents you're familiar with, right? So tangents are just you draw a tangent line, it touches the curve at the point. It gives you the gradient of the tangent is the gradient of the curve at that point, okay? Now I'm going to draw in a different colour. Now we're going to look at this other sort of line called the normal line, the normal, okay? And the normal is perpendicular to the tangent. So it's going to look something like this, and it's going to be perpendicular or at right angle to my tangent. So that's my normal, okay? So it's going to be perpendicular to my tangent line, okay? Right, and so that's the whole idea. A normal line is perpendicular to the tangent, okay? But it still intersects at the same point P, right? That's the key idea. They both intersect at the curve at the point P, right? So the tangent and the normal intersect at the point, but the main idea is the normal is perpendicular to the tangent, okay? So I'm going to note that down. So normal or normals are perpendicular to the tangents. And so in general, if I draw a little diagram, if you have a tangent line there, then the normal is a line that's perpendicular to the tangent at that point, okay? And that's what we'll be doing. What we'll be doing in this section using this idea is to find the equations of these two lines using, for example, y is mx plus c. Okay, remember when we looked at straight lines, even from GCSE, we will be using that to find the equations of these two lines. Okay, right. Okay. And by the way, if you see anything to do with normal, usually normal means perpendicular, right? That's usually what it means. For example, in mechanics, you will look at something called a normal reaction force. That's perpendicular to where you're moving, right? So if I'm moving here, then there's a force upwards that's called the normal reaction. But more on that, I'm not going to go into mechanics here, but anything to do with normal, you should think perpendicular or right angle, okay? Right, okay, so we're going to look at some examples then with this idea. So we need to find the equation of the tangent to the curve y is x cubed minus 3x squared plus 2x minus 1 at the point 3, 5. So again, the tangent, remember, it's the same gradient at that point. So we need to find a gradient. Anything to do with tangent, the normals, you need to be thinking gradient. But how do we find the gradient? Differentiation, right? So dy dx then, if we differentiate this curve, it's going to be 3x squared minus 6x add 2. okay, using the power rule. We've done many videos on this. Hopefully you're comfortable with the power rule and how we got to this derivative here. So this is the gradient function, so this is a derivative for all x, but I only want the gradient at this point here. So at, particularly when x is 3, right, dy dx is going to be, if I substitute 3 into my expression, so I get the gradient at 3, it's going to be 3 lots of 3 squared minus 6 lots of 3 add 2. If I put that in the calculator, I get 11, okay? So therefore, if I'm going to find the tangent, the equation of the tangent, remember tangents and normals, they're lines. Every line has an equation, y is mx plus c. But I know my gradient is 11, right? So therefore m is 11. So remember, the idea is a tangent has the same gradient at the point, right? The tangent is the gradient at that point, which we just found, okay? I can already say then that y is 11x add c. So I just need to find c. But this is where this point comes in, right? We're given the point 3, 5, right? That's x and y. X is 3, y is 5. I can substitute that in then. If I substitute the 3, 5, that 0.35 into my equation of the tangent, then y would be 5 equals 11 lots of 3, because x is 3, add c. Then I just need to solve for c. So 5 is going to be 33 add c, so therefore c, if I subtract 33, is going to be minus 28. So that now I've got my full equation. So the tangent is y is 11x minus 28, and that's my equation. Okay, so that's sort of the recipe, right? So we find the gradient at a point, then we use mx plus c to find m and c, okay, and the gradient will be from the derivative. Okay, cool. We're going to do something similar, but now we need to find the normal to the curve, right? So we're given the equation y is 8 minus 3 root x, that's my curve. I need the normal at the point where x is 4. So again, normals, we're going to need the gradient, because normal is perpendicular to the tangent, and we need the gradient for the tangent. So dy dx, well, firstly, we need to rewrite this as just index, as powers. I have root x, I need x. So I'm going to use the index law. So 8 minus 3, then root x is half, x to the half. So it'd be 3x to the half. Now I can differentiate. So then that's going to be, well, 8 is a number, it's a constant, and that will go to 0. So we're just left with minus 3x to the half. The half comes to the front, so it'll be minus 3 over 2. 3 times a half, minus 3 over 2. X, then if we subtract 1 from a half, from my power, that'd be minus a half. And that's my gradient, okay? But I want the gradient when x is 4. So when x is 4, then dy dx is going to be minus 3 over 2, 4 to the minus a half. Now at that point, you don't have to worry, unless you really have to. I wouldn't try to do it manually yourself. Try to simplify this. You can just whack it in your calculator. So if I do minus 3 over 2, 4 to the minus a half, we get minus 3 over 4. So the calculator does the work for you in most cases. Okay, normally they're not that mean when you need to simplify it by yourself. So we get this answer. So that's, again, so that means the gradient of the tangent is minus 3 over 4. The gradient of the tangent is the gradient that we get, okay? Remember, that's the whole idea of differentiating, to match the gradient of the tangent. But I need the normal. So that's going to be, the normal is perpendicular to a tangent, as we discussed at the start. Which means that therefore the gradient of the normal is perpendicular, or as the negative reciprocal. Well, firstly, the negative of negative 3/4 will be positive, right? Because it'd be a double negative. And then we do the reciprocal. So then it'd be 3/4 flips to 4/3. Okay? And remember, you can check your answer to show that it is perpendicular. Because if we times the two gradients together, minus 3/4 times 4/4, you should always get -1. Always, and that is true here. So, okay, that is my gradient. I can now start to sort of fill in my equation of the line, right, of the normal, because y is going to be mx plus c. That's just the general equation of the line. But I know my gradient is 4/3, so 4/3 x add c. I just need to find c, so I'm going to need a point on the line to substitute into that equation. But I don't have a point, but I'm only told x is 4. How can I then get the y coordinate? Well, I'm given the equation of the curve. So I can find y by substituting x in. So y is 8 minus 3 root x. Well, when x is 4, that's going to be 8 minus 3 root 4. And then that's going to be 2 overall. Okay? So therefore, my point is 4, 2. I can substitute that in then. So if I sub 4, 2 into here, into my equation of the normal, I get that y is 2, 4/3 of x, which is 4, add c. So if I simplify that, 2 is equal to 16/3 plus c. So therefore c, if I subtract 16/3 from 2, I get minus 10/3. So overall, my equation of the normal is y is 4/3 x minus 10/3. And there we are. Cool. Okay, so we've got an exercise question then. So we are told the point P with x coordinate 1/2 lies on the curve of equation y is 2x squared. The normal to the curve at P intersects the curves at point P and Q. So we're going to again need to find this equation of the normal at P. So we're going to then need to differentiate, right, my curve to find the gradient and so forth. Well, firstly, my curve is y is 2x squared. So if I differentiate it, that's going to be 4x. So then I need my gradient, right, at the point P. Now P, the x coordinate is 1/2, right? So if I substitute x as 1/2 to get the gradient at the point P, I get dy dx, my gradient, is going to be 4 lots of x, which would just be 2. So that means the gradient at P is 2. And actually the tangent at P, so the gradient of the tangent is 2. But we're looking for the normal. So again, the normal is perpendicular to the tangent. So we're going to need to do the negative reciprocal. So the gradient of the normal then is going to be negative 1/2. And so therefore I can start to deduce the equation of the normal line is y is minus 1/2 x plus c. So again, I need a point. Well, again, I'm in the same situation where I'm given the x coordinate of 1/2. How do I find the y coordinate? How do I find the point P, x and y? How do I find the y coordinate? I'm given the curve, right? So then I can say that y, if I substitute 1/2 into the curve, y is 2x squared. That's going to be 2 times 1/2 squared. That will get me 1/2 overall. So there we are. So the point P is simply 1/2. Okay. So therefore I can substitute this into my equation. So therefore y is 1/2, is minus 1/2 of x, which is 1/2. add C. So a half is going to equal minus a quarter, add C. So if I add a quarter to both sides, I get X is a half, C is a half, add a quarter, which is 3/4. So therefore I've got my equation of the normal. Right, so my full equation of the normal is y is minus a half x add 3/4. Cool. But that's not really the question. We needed to find that, but we're actually told the normal to the curve at P intersects the curve at points P and Q. So we've got the equation of the normal. We're told it intersects this curve, right, at 2 points P and Q. Well, we found P already. We just need to find the Q. Well, it's talking about intersections. So my normal intersects curve. This seems like simultaneous equations, right? So remember, my curve has the equation y is 2x squared, and we just found the normal is minus a half x add 3/4. So the curve is intersecting the normal line, so we can equate them together as simultaneous equations. So therefore, that if we substitute one equation into the other here, we're going to get minus a half x add 3/4 is 2x squared. So then I can move everything to the right. So then 2x squared add a quarter x minus 3/4 is equal to 0. And I can tidy this up a little bit by getting rid of the fractions, although you don't have to, by timesing everything by 4. So then 8x squared add half times 4 is 2x minus 3 equals 0. I can now solve this equation, right? So then x then, if I say let's use the quadratic formula, that's going to be minus 2 plus or minus the root of 2 squared minus 4 lots of 8 times minus 3 all over 2 times 8. So then I get the solutions. X is x is a half, or x is equal to minus 3/4. Right, okay. But pay attention. We're told that they intersect at points P and Q. We already found what P is, right? P is when x is a half. Well, we've already got, that's my first solution here, x is a half. This is P. Well, that means the other intersection is Q, so that means x has to be minus 3/4 at Q. So Q is then going to be minus 3/4 and then y, right? How do I find the y value then? I can substitute x is minus 3/4 into either equation here. So that means if x is minus 3/4, then y is going to be, well, 2x squared, that's my curve. If I substitute that point x in, that's going to be 2 times minus 3/4 squared, which will get me nine over 8. Therefore, my final point Q, x is minus 3/4, y is 9/8. And there we are. So that's the coordinates of Q. Cool. Okay, so there's a lot of stuff going on there, but really when you break it down, hopefully it's not too bad. We just, again, finding the normal by differentiating, doing the perpendicular because it's perpendicular to the tangent. Then we substitute points in and then equate stuff together because they're intersecting. And there we are. Okay, we're going to finish off with an exam question then. We are told that figure 2 is a sketch of part of a curve C with equation y is a third x squared minus 2 root x add 3. Probably best to note that down. Now, we're told the point P, you can see here, it lies on the curve and has x coordinate 4. The line L is a tangent to the curve at P. You can see that line there. Show that the line L has this equation here. So basically, what is it asking to do? We're told L is the tangent. We need to find the equation, right? We need to find the equation of the tangent at P. So then we're going to use our sort of normal method then that we've seen so far. So we're going to need to differentiate to find the gradient, because tangents is all about the gradient, right? So then dy dx then. Well, firstly, we're going to need to simplify this root x term, right? Because we need it as a power. No root x is just x. So we can simplify to say third x squared minus 2, then x to the half, right? Add 3. Then we can differentiate. If we differentiate, well, a third times 2 times by the power, that's 2/3 x, and then we knock 1 off the power, so it's just 1. Then, for the next term, minus 2 times a half, that's just minus 1. So it's minus x, then a half minus 1, knock 1 off the power, it'd be minus a half. And then the number at the end, the 3, goes away because it's a constant. All numbers with no x's just go to 0. We saw that in an earlier video. Okay, so that's my full derivative, simplified. Now, we are told the tangent is at the point P, and P, x coordinate is 4. Basically means x is equal to 4, right? So that means we need to find the gradient at 4. So when x is 4, then the gradient dy dx is going to be 2/3 of 4 minus 4 to the minus a half. We can try put that in the calculator, see what happens. We get 13/6. Okay, cool. So that's my gradient of the tangent, right? So the gradient of the tangent is 13/6. Cool. So we can start to look at doing our formula, right? An equation for the tangent. So y is mx plus c, but we know the gradient m is 13/6. So 13/6x add c. So we need to find c. Well, again, we need a point. We know the tangent is at the point P, right? The tangent to the curve at point P. We know P is on the line. We need to find P as a coordinate. Well, we're told the x coordinate of P. The x coordinate is 4, but we don't have the y coordinate, right? We can again then find the y coordinate by using the curve, right? So the curve is y is a third. So x is 4, y is going to be a third x cubed, is it? No, squared. Minus 2 root x add 3. Okay, so that's my equation of the curve. So then to find the y coordinate when x is 4, that's going to be a third of 4 squared minus 2 root 4 add 3. And then if I do that, I get I get 13/3, 13/3. So then my point P is 4 13/3. Now I can substitute that point P onto my tangent, okay? Because again, the tangent is at the point P to the curve. So I sub 4 13/3 into here, into my equation. So then y, well, y is 13/3 is equal to 13/6, lots of 4 for x, add c. So then if I can simplify this, so then 13/6 times by 4 is equal to 26/3, add c. Then I subtract 26/3 to both sides, so c is going to be 13/3, take away 26/3, which is minus 13/3. So my final equation is y is 13/3x, right? 13/6x, my apologies, minus 13/3. Okay, so that's my equation of the tangent, that's L, right? But they want it in this form, so we just need to rearrange a little bit right here. So we need to make it look like this. Well, I notice first of all everything is on one side and it equals 0. So let's move everything to one side. So then that's going to be minus 13 over 6x plus y add 13 over 3 is equal to 0. Now, I need to get rid of the fractions, right? Because there's no fractions in the answer, and that the one. We can get rid of the fractions, tidy this up. Well, if I times it by 6, I get rid of this fraction here and this one, right? Because obviously 3 goes into 6. So what I'm left with then is minus 13 over 6x times 6. Well, minus 13 over 6 times 6 is just minus 13x. Add 6y. Then 13 over 3 times 6, that'd be plus 26 equals 0. Let's check the let's check our final answer. It looks pretty much identical, but I need to switch the negatives around. I have 13x minus 6y. Here I have minus 13x add 6y. So I need to then divide or times, whatever you prefer, by minus 1. It's the same thing, right? If I times by minus 1 to make flip all the signs, I get 13x minus 6y minus 26 equals 0. And that should be the form they've got. Yes, it is. And cool. So there we are. And that's it. Cool. So yeah, so again, so most of this is really just finding equations of lines, which we did look at in chapter 5 when we looked at straight lines in detail. But again, you need to recognize that differentiating gives me the gradient of the tangent, right? Then the normal would be perpendicular, okay? And that's all that's the new thing we've looked at here. So if I go back to the start, the whole idea is that the tangent is perpendicular to the normal and the tangent is the gradient at the point. Okay, so we differentiate. Okay, so that's tangents and normals. I'll see you next time.